Hey everyone, in this lesson we are going to be continuing on with our next mini project. Now this one is going to focus on collision and collision detection inside of Godot. So in this mini project we are going to jump back to 3D and create a little skiing game where the player is basically being pulled down by gravity down this hill, and they are going to be using the left and right arrow keys in order to move, well, left and right to avoid the trees that we are going to place in the way. Now if the player hits a tree, then that is going to restart the level. Okay, so collision detection is basically where we are detecting when two colliders have bumped into one another, and then we run a function on one of those objects. So what we're going to be learning is 3D physics, which is going to extend from what we learned in 2D physics, as well as collision detection, which is going to extend over to the scripting side. Alright, so inside of Godot, what I'm going to do is go ahead and create a brand new folder for this mini project. So I'm going to create a new folder here, and this one is going to be called Collision. Next, what we're going to do is create a new scene for our collision mini game. So I'm going to go up to Scene at the left, go New Scene, and since we are creating a 3D game, I'm going to create a new 3D scene. I'm going to rename the root node to be Main, and then I'm going to save this to our collision folder as collision.tscn. There we go. So if we open up that collision folder now, we should see that scene saved there. Now with this game, we are going to be using a pre-made 3D model which has a material and textures as well. The reason why is we might want to give our game a bit of flair with our own custom model. We already done that with the balloon popper, so let's do it again. Now in the course files tab, there is a downloadable zip containing all of the assets for this course. Simply download that, extract the contents to your computer, and inside you should see a collision folder. Now inside of collision, there is a textures folder which contains a color map as well as a material and model file. This is basically all we need to have the 3D model, which is this 3D object file. The material basically defines how the texture is then applied to the model. So I'm going to select all three of these things and drag them into our project here. Okay, that's going to begin the import, and we should then see inside of our collision folder, we have a textures folder which has the color map PNG, and we then have our character female b.obj. Now if I drag this in, just like with a Sprite 2D, it is going to create a new instance of Mesh Instance 3D, which is the node type that renders 3D models. And as you can see, here we have our 3D model with all of its texture applied. Now this is a model from the kenny.nl website, which is a great resource if you want a bunch of free public domain assets for your game. So we'll be using this one. Now, before we start coding in everything from the player movement to the collision detection, we first of all need to build a bit of an appropriate environment. Okay, so I'm just going to delete this node right here. And by appropriate environment, I mean we need to create, first of all, a ski slope. And then some trees, as well as changing the background, because this doesn't really look like a skiing background now, does it? Okay, so what we're going to do is we're going to begin by creating ourselves a ground. And this is what we're going to have our player essentially ski down. So what I'm going to do is I'm going to create a brand new Mesh Instance 3D node. This one I'm going to rename to be Ground Model. And then what we're going to do is go over to the inspector, go over to mesh, and we are going to choose a mesh for our ground. Now I'm going to choose box mesh right here, which is essentially going to be a cube. But what we're going to do is scale it and stretch it out. So if we go down to transform, what we can do is go down to the scale properties. And if I start changing the scale, you'll notice that all three axes get changed uniformly. Well, we don't want that. So I'm going to click on the little lock icon here to unlock each of these individual axes. I'm going to start by setting the Y to be 0.3, so it's a bit thinner. I am then going to set the X scale to be about 12, so we're going to have a width of 12. And then for the Z, this is going to be about 30, okay? So this is basically how long our ski track is going to look. Next, we need to rotate our track so that we're going to actually have our player slide down it. So I'm going to make it about, let's just say minus 20 degrees, like so. And then what we're going to do is we need to attach a collider, because right now, if we were to press play and have our player in game, they would fall right through this model because there is no collider on this cube to actually make it a solid thing in the world. Right now, it is just a visual, essentially like a cloud. So what we're going to do is we need to make what is known as a static body 3D node. Now, a static body 3D basically acts as a solid object in our world. So I'm going to create a brand new static body 3D, and I'm going to click create. I'm going to call this one our ground. And then what I'm going to do is drag the model in as a child of ground. And we'll see that we have a little exclamation mark on ground, which is basically saying we need a collision shape in order for this to work. So as a child of ground, let's then create a collision shape 3D. And then basically we want to make this fit the bounds of the model. So I'm going to go over to shape. I'm going to make this a box shape 2D. And then if we click on box shape 3D, and if we click on that, we can then change the size. Now I'm going to make this the exact same dimensions as our scale. So for the Y, I'm going to make that 0.3. For the X, I'm going to make that 12. And for the Z, I'm going to make that 30. Now we simply just need to rotate this. So I'm going to rotate it. Let's open up transform and make sure the rotation is at that minus 20.3 that we had. Okay, and there we go. So now we should have this collision shape basically fit the bounds of this model. And if we zoom in, we should see that it is pretty much perfect. Okay, and there we go. So now if we were to have a solid object fall, it would hit this slope and slide down. Now, next up, let's add in a bit of a sky, because right now our sky is pretty bland. Well, in fact, I'm going to make it a bit blander, but we're going to make it fit the theme of it being cold. So what I'm going to do is create a new world environment node here. By default, it has that red background because we did change the clear color. I'm going to go over to the inspector, add a new environment to the environment property, then open it up, go over to background, change it from clear color to custom color, and then the color we are going to make a nice blue, okay, it's a nice light blue, something like this. There we go. And I think that is all we're going to do for our world environment. You can of course go in and add in your own changes, but something else, and that is also a directional light. Now, at the moment you can see that our mesh is lit, but this is only what we are seeing in this viewport here. If we were to press play, well, first of all, we wouldn't see anything because there's no camera, but if we were to add in a camera, this ground would be dark. So we actually need to add in a directional light as well. Let's then move it up. We then want to angle it down so it is actually pointing at our ski slope here. And then let's go down to shadow and enable shadows as well. So when we add in our character, let's drag them in, you can see they now have a shadow being drawn as well. We can then delete them again because we don't need them just yet. And that is our environment setup. Now, the only thing that is missing are the trees. As a bit of a challenge, I want you to go ahead and attempt to create the tree model. This is essentially going to be a cylinder combined with a number of different scaled spheres, and make that a child of a static body 3D node with a collider. And then as a bit of a bonus challenge, if you want, try and add materials to those models to make them look, for example, green for the leaves and brown for the trunk. Now that's quite a few steps, but see how far you can go in creating the tree. So I'll be right back to see how you're done. Welcome back everyone. So I hope you had a go at that challenge. Pretty much what we're going to do is we're going to start by creating ourselves a static body 3D node right here to represent our tree. And then what we're going to do is we are going to rename it to be tree, just like so. And now let's lay out the basic shape using different mesh instances. So as a child of tree, I'm going to create a new mesh instance 3D. This is, I'm going to call trunk. And I'm going to make this mesh of type cylinder mesh right here. Okay. Down inside of transform, what we can do is I'm just going to bring this up so that the base of the tree, which is the origin down here, is going to be the tree trunk right there. There we go. And now what I'm going to do is just shrink down the sides a bit so it's not as thick. So for the scale, I'm going to set the X to be 0.75. Same thing for the Z. So you have a bit of a thinner tree right there. Now what we're going to do is create the leaves. Now for the leaves, I'm going to have a number of different circles. So another mesh instance. I'm going to rename this to leaves. And I'm going to make this a sphere. I'm going to move it up. I'm going to increase the scale a bit here, and then I'm going to shrink it down like that. Alright, something like this. And then what I'm going to do is I am going to duplicate it, move it up a little bit, shrink that down a bit, duplicate it again, move it up, and then shrink that down as well. So now we have this sort of tiered tree look. And in fact, we can probably make the top sphere here a bit more circular just because it's at the top of the tree. Something like that. Now, if you wanted snow-capped tree leaves, you could probably leave it as is, but we're going to add in some materials now for the tree and for the trunk. So, down in the collision folder, I'm going to right-click and create a brand new resource, which is going to be of type material. But you can see there are many, many types of materials. We're going to go down to standard material 3D and create that. This one is going to be called tree underscore trunk. And then what we can do is drag it onto the trunk and it should be applied like so. Next, we'll just double click on that tree trunk material, go over to the inspector where we have all of these settings. I'm going to go to albedo and I'm going to change the color here to be a nice brown tree trunk color. Okay, so we can basically go through this, try and find the right color for that. I'm going to make it actually a bit brighter, just so it's a bit nicer to see. Something like this, I reckon. There we go. So we've got our tree trunk. Now we just need our leaves. So I'm going to create another material here. This is also going to be of type standard material 3D, and I'm going to call this one tree underscore leaves. We can then drag that onto each 3 of these little spheres here. Now, of course, if you do have a custom tree model that you want to use, you can, of course, use that one instead. But we are just looking at how we can sort of create models inside of Godot without necessarily having to import a model or use a modeling software, okay? You can create models inside of the engine. Although fairly simple, they do the job. And there we go. We have our little tree. Now, what we're going to do next is add a collider to our tree because at the moment it just exists as a visual. So I'm going to right click on tree, add child node, create a collision shape 3D. And the collision shape for this one is I'm just going to make it we'll make it a cylinder and just make sure it fits the bounds of this tree trunk here. So we might want to decrease the radius a little bit. And there we go. So there we go. We have our tree, we have our collider. Next step is to save this tree as a scene so then we can begin duplicating them and placing them around our track. So I'm going to drag tree into the collision folder, save that as tree.tscn, and there we go. Now what we can do is essentially just move this tree around our level here and begin duplicating it. So might have one there, might have another tree over here, move that over a little bit. Might have another one down here. So yeah, just go through and begin placing in your trees. Okay, and there we go. So we now have our trees placed down on our level, ready to be dodged. Now, one more thing that we are going to do on our tree model that is going to be very important for later on is going to be adding what is known as a group to the tree. So if I open up my tree scene by just double clicking on it, what we're going to do is select the root node. Then over in the inspector, we're going to go to the top where we have the node panel right here, and then go over to the groups section. And here is where we can assign a new group to the tree. Now, what is a group? Well, essentially, a group acts as a way of tagging or categorizing scenes or nodes. So when we eventually detect collisions with our player, we want the player to know what they hit. Okay, if the player hits the ground, we don't want to restart the level. Only if the player hits a tree do they want to restart the level. But by default, the player doesn't know what a tree is, what the ground is. It sees them all as objects it is colliding with. So what we can do is put the tree in the tree group. So when we collide with it, we can go, okay, is this object in the tree group? If so, it's a tree and we should restart the level. So I'm going to click on the plus icon right here and give our group a name, which is just going to be tree, and click OK. Now you should see under scene groups, tree, and as a tick. So now this tree node, which contains the models and the collider, are a part of the tree group, and we can then detect that later in script. So in the next lesson, we are going to be looking at setting up our player object, which is going to be the thing that will fall and slip down the map right here. And then in a future lesson, we'll look at actually adding in a script to move left and right and detect collisions. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be setting up our player. So what we're going to do is create our player node using a rigid body node, because we want our player to basically fall and slide down this track here using physics. So what I'm going to do is I'm going to start by creating a new rigid body 3D node right here. Let's bring it up to the top of the track as well, and I'm going to rename it to be player. Now let's just move it up in the hierarchy here so it's at the top. We're then going to give our player its 3D model. So let's go over to the collision folder, drag in that 3D object like so, make that a child of player, rename it to, we'll go player model, and then we want to go to transform, set its position to be 0, and then we also want to rotate it to face the other direction. So I'm just going to rotate it around like that, and make its Y rotation 180. So there we go. We have our player, and we have its model here. Now next up, let's add in an actual collider for our player so they can actually hit the ground, not just fall straight through it. So we'll add in a collision shape 3D. This is going to be, we'll make it a box, I reckon, just so the player doesn't start rolling. So we can then make it fit the bounds of them. It doesn't have to be too exact, it just has to be the rough shape of the player here. Okay, something like this. Move it up so that their feet are covered, and there we go. We'll make it actually a bit longer as well, since they'll be sliding down. We probably don't want them to flip over forward. And then we could also just move it back like that a bit as well. Now, before we press play and test it out, we actually need to attach a camera to our player. So I'm going to attach a camera 3D node to our player. And using the little preview window in the inspector, we can actually see what it looks like when we position it. So I'm going to put it here, tilt it down a little bit, something like that maybe. So now if I press play, we should see that our player will fall and land on the ground. But they're not moving, they're not sliding down. Why is that? Well, the reason why is because by default, the physics settings are not set up to actually have the player slide, okay? Typically in a game, you don't really want your player sliding around on surfaces, so we don't have that enabled by default. So what we need to do is select our rigid body, and in the inspector, you'll see there is a physics material override. Now, a physics material basically defines what the surface of the player is, okay? Is it rough? Is it smooth? Is it slippery? Is it bouncy? This is something we can set up here. So I'm going to create a new physics material, open that up, and what we need to do is go to where we have the friction setting, okay? So right now our friction is set to 1, meaning that this thing is not going to slide at all. So I'm going to bring this down to 0, which basically means that there is no friction at all. And if I save that, then press play, what you'll see is the player will fall and begin to slide. Okay, they'll hit the tree, slide around, and fall off the edge. So you can see how you can create some pretty interesting games using physics inside of Godot. You can try that again, and of course the exact same thing is going to happen because we have changed nothing of the starting parameters. But yeah, that is the physics working. Now one more thing I am going to do is to just make our player have little skis, just because, well, they are skiing down a hill, so I think it is appropriate. So I'm just going to add in 2 mesh instances here for a ski. This is of course just going to be of type, where is it? Box mesh. We can then scale this down, stretch it out, shrink it down a little bit, and just make it fit the bounds of the player's feet. There we go, so we got 1 and 2. Now if I press play, you can see that our player is now going down with some skis. Let's also then just add a color for that, but you know what we can do? We can actually recycle our existing colors. So I'm just going to make these some nice green skis here. Okay, and that's something you also should be doing in games, recycling materials, textures. It just saves on the amount of work that you have to do, and also saves on the amount of work that your computer has to do with loading in those resources. So now that we have our player set up, we need a way of actually moving them, because right now, as you can see, the keyboard arrows, we do nothing. We simply just keep going down this hill and bump into the tree and fall off the edge. So in the next lesson, we are going to be looking at creating our player movement script. Welcome back everyone. In this lesson, we are going to be setting up our player movement script. This is going to take in our keyboard arrows and allow us to move to the left or to the right. So what we're going to do now is select our player node, and then in the inspector, go right to the bottom where we have the script property. We're going to create a new script here. This one is going to be called player movement, and it's going to be inside our collision folder. So click create, and it's going to create that script right here. Now you can see it is extending from the rigid body 3D node which we attached it to, meaning we have access to its variables and functions. So that is how we are going to actually move our player around, by modifying its linear velocity. Now for this we're going to create a variable called move speed of type float, which is essentially just going to be how much force we are going to apply to the left and to the right. So we want to also be able to change this in the editor or in the inspector. So I'm going to add the @export tag at the start so that it appears here in the inspector. Next, we are going to create the function called not process, but physics process. Now, physics process is a very similar function to process. Okay, process gets called every frame, and if you would actually put like a print line in here, you would see that physics process also gets called pretty much every frame, but there is a distinct difference, and that has to do with how physics in Godot works. The Godot physics engine works on a different, I guess you could say, system than the normal game loop. Okay, because when it comes to physics in games and in game engines, you want it to be consistent, okay? And to make it consistent, you want to update the physics objects and detect collisions at a set time rate per second. I believe Godot's is around 50 or 60 times per second, in which it detects physics and updates physics, whereas the process function gets called, you know, it could get called 5 times a second, 100 times, 1,000 times a second. It will go up and down depending on your frame rate. But the physics engine runs on the exact same time step per second. And that is what the physics process function does. It runs at a fixed time step per second. So in here is where you basically want to do all of your physics update code. You shouldn't really be doing physics related code inside of the normal process function. It's general practice to do it inside of physics process. So in here, what we want to do is basically move left when we press the left arrow key and move right when we press the right arrow key. So what I'm going to do is I'm going to write if and then input dot is physical key pressed, and then we're going to search for key underscore left. Now, is physical key pressed is going to return true if the given key is being pressed this frame. So when we are holding down the left button, this is going to be true. And in fact, let's run a little print line of code here, which just says move left, just to see if it works. So I'm going to save that, press play. Now, if I hold down the left arrow key, you can see in the output that it is printing out those lines of code, which is great. Now, how do we actually get our player to move left? And what we want to do here is write down the function apply underscore force. Now apply force, basically we give it a vector and it is going to gradually push us in that direction at that speed. Okay, this is different than apply impulse, which is what we used in the previous mini project. Apply impulse is like if you're hitting a golf ball with a golf club. Apply force is if you're trying to push a very heavy object. So what we want to do now is basically give it a direction and then multiply it by our move speed. So the direction is going to be vector 3 dot left, which basically is -1 on the x-axis, 0 on the y, 0 on the z, and then multiply that by move speed so that we can have it go at a rate of 2. Now when I press play, what you'll see is when I press it, we kind of spin off to the side, which is a bit strange. Now the reason why that's happening is because we need to have a look at our setup here, okay? When we are applying this force, it is applying it from our rigid body's origin position right here. But you may notice before that we actually moved our collision shape over backwards a bit. And it's important to note that our collision shape is what defines the volume of our actual rigid body, not the models itself, okay? The collision shape is what defines the volume. Now, if we are pushing about 2/3 the way up in front of the model here, it's going to make it start spinning. It's going to turn it to the left and make it start spinning that way. So what we need to do is basically center our collision shape so that it is being pushed perfectly from the middle. So on the Z, I'm going to set that back to 0, so it's just like that. Now if I save that and press play, you'll see that we now get a much more uniform push to the left. Okay, and finally, let's make it so we can push to the right as well. So here I will go elif input.is physical key pressed, key underscore right. Then we are going to go apply force, vector 3.right multiplied by move speed. And there we go. So now we can play that and we can move left and we can move right to dodge the trees. But again, it is pretty hard. So if I try that again, you can see we can dodge the trees, but we kind of got to time it all perfectly. And there we go. Now, in the next lesson, we are going to be looking at detecting collision with our trees, okay? Making it so that we can call a function when that event occurs, and then restarting the level. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be setting up our collision detection with our trees. So, in the previous lesson, we set up player movement so they can actually move left and right like so. Whoops, we started moving before we hit the ground. But now what we want to do is make it so that when we hit a tree, it is actually going to restart the level. So first of all, we need a way of actually having a function inside of our player script call when we hit a tree. So how can we do that? Well, what we're going to do is select our player. Then in the inspector, we're going to go up to the node panel, go over to the signals area, and inside of signals, we have a list of things here. Now, what is a signal? Well, you can think of a signal as like an event, okay? It is something that gets emitted when something happens. For example, in Rigid Body 3D here, you can see we have the body entered signal, which basically means that this signal gets emitted whenever our character's collider enters another body, such as a static body, another rigid body, an area body, stuff like that. We have input events, we have mouse entered, so if our mouse enters the player's collider, that signal will be called. Visibility changed, if the visibility is toggled on or off, that signal gets called, and so on and so forth for all these other ones here. Now, what we are going to do is connect to the body entered signal, because when a signal gets emitted, it doesn't just emit into the void. What we can do is connect functions to signals. So we are going to have a function inside of our script that will be called when the body entered signal is emitted. Now, to set this up, we're simply going to double click on body underscore entered. We are then going to select our player node, which contains the script, and select connect. Now, what that's going to do is create a brand new function inside of our script here. And you'll see we have this little green icon basically telling us that this function is connected to a signal. So, on body entered, like I said, this gets called when our collider enters the body of another, which is like a static body, meaning our ground, our trees. So let's actually see if it works. But before we actually write any code, we also need to go over this parameter. The parameter that gets sent over is body, and this is essentially going to be the other node that we hit. So what I'm going to do is I'm actually going to write a line of code here that is just going to print out the name of whatever node we hit. So I'll print body.name. Now if I go ahead and press play, it should tell us when we hit a tree that we hit a tree, but not even the ground, okay? We hit the ground at the start of the game, we hit a tree, but there's nothing out here in the output. Why is that? Well, by default, our rigid body is not going to actually detect collisions in the sense that it calls it back through the signal and into the script. The reason why is because most of the time rigid bodies are just going to be used for things that bounce around the scene and collapsible bits of wood, stuff like that, and rocks, so we don't really need them interacting with the scripting side of things. And that saves on performance, but we do want this rigid body player to actually emit a signal. So to do this, we are going to select our player, and then down inside of the solver settings right here, we are going to enable contact monitor. This basically means that, as you can see, if true, the rigid body 3D will emit signals when it collides with another body, which is exactly what we want. And also max contacts reported. This is essentially how many different contacts will be sent over in the signal. This is if you want to actually get into the nitty-gritty of collision detection. We don't really need to worry about this, so I'm just going to set it to be 1. Now if I press play, you'll see that in the output it says ground, then tree, then ground, and we keep falling and hitting the tree, hitting the ground, and it keeps printing out to the console. So that's great, but what we now need to do is make it so that when we hit a tree, the scene restarts. But we don't want to restart when we hit the ground. We only want to restart when we hit a tree. Now that is where that tree group comes into play. Remember, when creating the tree, we created the tree group. So what we can do is we can go if body.is in group, and we call this function, sending over the group name, which is tree. Then we can print restart level. Okay, let's see if that works. So I'll press play. As you can see, the ground, it said nothing, but if I hit the tree, it says restart level. As I'm on the ground, it doesn't say anything. Only when I hit a tree does it say restart level. But how do we actually restart the level? Well, what we have to do is call a function called reload current scene. So to do this, we first of all get the scene tree, and then we go dot reload current scene. And this right here is basically just going to reload the collision scene. So now if I press play, as you can see, if I hit a tree, it is going to reload the scene and allow us to keep on going down each time we hit a tree. So the collision detection is now working, which is great. But there is one little issue, and that is we are getting some errors down here in our debugger. So if I go over to errors, you'll see here we have these 4 errors. And the reason why this is occurring is something that's not necessarily our fault, but it's just something about how the Godot engine works, okay? We don't have to understand exactly why this is occurring, but basically we are trying to reload the scene when a collision detection has occurred, which has some issues in the sense that we can't actually unload an object before the physics frame has ended. So the way we can get around this is by calling the reload current scene function at the end of the frame rather than exactly when the collision occurs. So how do we do that? Well, we can do that by deferring the call. Deferring the call basically means we hold off on reloading the current scene at this current time, wait the very short amount of time before the frame has finished doing everything it needs to do, and then we call the function. So to do this, we are just going to go reload current scene and then go dot call underscore deferred. And this right here is going to defer that call so it gets called after the frame has run. And that should then solve the issue. So if I press play again and hit the tree, you should see down in our debugger, we no longer have any of those errors, which is great.